Alright, so today we're going to look at adding positive and negative integers. And we're going to do that using some of the methods that we used when adding just negative integers or when we added just positive integers. But this time we're going to mix them together. We're going to have some positive and negatives in the same problem. We're going to use the same methods to solve it, and we're going to find that those methods will work and will give us the right answer every single time. So the first thing we're going to do is we're going to start with a relatively simple problem, and we're just going to use the three different methods that we talked about previously to add these two integers together. So let's start with something like this. Let's say that I were to give you negative 5 plus 6. Okay, so that's our goal, is we need to add negative 5 and 6 and see what kinds of answers we can come up with. Okay, so the first method that we talked about previously was just using positives or plus signs and minus signs to represent positive and negative numbers. So in this problem, the first thing we're going to look at is negative 5. If we have a negative 5, what do we use to represent that? Hopefully you remember that the answer would be we are going to use 5 negative signs to represent negative 5. The second part of this comes from the plus 6, and to use that we're going to use plus signs. So we have 1, 2, 3, 4, 5, 6 plus signs. Okay? Now when we solved these problems before, when we would add a positive and a negative, or a positive plus a positive, or a negative plus a negative, all we had to do was count up how many minus signs or negative signs we had and how many plus signs or positive signs we had, and that was our answer. The problem with that here is that we can't do that. There's no such number as positive negative 5, 6. That doesn't make any sense. But what we do need to remember is when you have a positive and a negative, they cancel each other out. They create what we call a zero pair. Okay? And you can think of it in this way. Let's say that you owed your parents $1. Okay? So you owe your parents $1, and your grandma gives you $1 when she comes to visit you, just for fun. When you pay your parents back, you have no money. You don't owe anybody any money. You don't have any money. It's a zero pair. It canceled out the money that you owed your parents. So if you have a 1 and a negative 1, they cancel each other out. Same thing with this. Anytime that you have a positive sign and a negative sign, or a positive value and a negative value, it cancels each other out. So if we're looking at our problem here, one of the things that we can say is that anytime that we have one positive and one negative, that's a zero pair. So in this problem, altogether, we have 5 different zero pairs. Each one of those has a value of 0. So this would be like saying 0 plus 0 plus 0 plus 0 plus 0, which of course is 0. And then we're left with one last value at the very end. And this last value is the value that we're actually looking at as being our answer. So this right here, this one positive sign is our answer, and one positive is representative of positive 1. So that's how we solve that problem, is we just look at it and figure out I have one value that was not canceled out in a zero pair, so all I have left is that one value. If we were to use a number line for this, okay, let's draw our number line here. There we go. Here we have negative 5, negative 4, negative 3, negative 2, negative 1. I may not have made this number line quite big enough. Just barely. Okay, so we have negative 5 plus 6. So just like before, we're going to start at negative 5 because that's the first value that we had in our problem. So here's negative 5, and it says to add 6. Now remember, when you add a positive number, because 6 is positive, we move to the right. So I need to move 6 spaces to the right. And when I do that, I end up on an answer of positive 1, okay, which is exactly what we got in our first problem. Now if we use the t-chart, and this time the t-chart's not going to be too helpful. It's going to be more helpful when we have more numbers that we're dealing with. But if we use the t-chart, and we'll just use it now just to make sure we understand what's going on, we have positives on one side and negatives on the other. So I have a 6 and I have a 5. Those are my two values. And when I bring that down to the bottom, if I add up the left column, I have 6. If I add the right column, I have negative 5. Okay? Now you'll notice that in this case, the numbers got switched around. But that doesn't change the value, because if you were to use this as just a normal problem that you've had since like 2nd grade when you were doing subtraction, or 1st grade for that matter, this you could read it as 6 minus 5. And it's written right there, 6 minus 5. 6 minus 5 is something that all of us can do. 6 minus 5 is 1. So as long as you have it written where you have your positives on the left and your negatives on the right, then you can just read it as a subtraction problem, 6 minus 5. And you just subtract those two numbers. So 6 minus 5 would be positive 1, which is again the answer that we got when we started. Okay, so those were all relatively simple problems, so let's make it a little more difficult, because let's face it, that's what's going to be happening for the rest of the year. So here we go. Let's try this problem. We're going to make this one a little bit longer also. Let's say I gave you negative 3 plus 5 minus 3 plus, let's say, 4. Okay? So there we have our new problem. We have to figure out what does this problem actually equal. Okay? First thing that I want you guys to remember to do. Right here you'll see that we have a minus. Okay? Subtraction or minus does not exist in pre-algebra. We don't do that. Okay? What we do instead is we rewrite this. Negative 3 is the same thing as minus 3. So we can rewrite it, instead of saying negative 3 plus 5 minus 3, we can rewrite it as negative 3 plus 5 plus negative 3. Okay? So that's your first step. Anytime you guys see a subtraction problem, I want you to rewrite it as a plus negative. And that just helps you remember that that 3 is not being subtracted and it's not positive. It's a negative number. It's a negative 3. Okay? So now we're going to go through and we are going to write in all the positive values and we're going to write in all the negative values. So let's start with the negatives. So here we have negative 3, which would be 3 minus signs. And we have another negative 3, which is another 3 minus signs. Next thing we're going to do is we're going to write in the positive signs. So here I have a positive 5, which is 5 plus signs or positive signs. I have a positive 4, which is another 4 positive signs. And now that I have this, all I have to do is I have to find my 0 pairs. So remember, a 0 pair is a positive and a negative. So there's a positive and a negative. That's a 0 pair. Here's another 0 pair and another 0 pair. And here's another thing that I want you guys to understand. Just because these two positives down here underneath don't have negatives right next to it, it doesn't mean that I can't also do this. Okay? There's another 0 pair and another 0 pair. And then I have my third negative sign, which can match up with that positive sign. Okay, and the reason that I do that is now I have nothing left on the left part of the problem. The only thing that I have left is what I have on the right side of the problem. And that, in this case, is these 3 plus signs. 3 plus signs means that my answer is positive 3. Okay? Now, if we're going to do this on a number line, it's going to get a little bit messy. So the number line isn't always the best option, but it can be used, so we're going to use it. Just to show you that it can actually be done. Okay, so we're just going to start over here at negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. I think that should be enough. Okay, so just like before, we are going to, what I'm going to do is I'm going to use a different color for everything that we do. So the first thing we're going to do is we're going to go negative 3 plus 5. So I'm going to go 1, 2, 3, 4, 5. So this is where I've gotten so far. And remember, this is not our final answer. This is just our answer at this point in the problem. The next part Okay, if we go back to our problem, we had negative 3 plus 5, and then we have, if we look at the part that we rewrote, negative 3 plus 5 equal, or sorry, scratch that, negative 3 plus 5 plus negative 3. So from that point that we just ended on, we're going to add negative 3, which means we're going to have to go back the way we came 3 spaces. Okay, so our first step was going negative 3 plus 5, and then we had to add negative 3, so we moved back 3 more spaces to add the 3 negatives. And then our final step is to add in the last part of the problem, the plus 4. So from that point that we just ended on, we're now going to add 4 more spaces to the right, and look where we ended up. We ended up on positive 3, which is the answer that we got when we used our pluses and our negatives. Okay? Okay, last part. We are now going to look at the t-chart. So I have a plus, I have a minus, or positive and negative, and this time this t-chart actually does come in really handy. It's going to help you guys understand where all these different values come from, and it's kind of a way to simplify everything into a smaller problem. So first we're going to find our positive numbers. We had a positive 5, and we also had a positive 4. So those both go on the left-hand side. On the right-hand side, we had a negative 3, and we had another negative 3. So when we get to this point, we are going to add together both of the values or add together both columns. So I have on the left-hand side, 5 plus 4 is 9, and on the right-hand side, 3 plus 3 is 6. And again, remember that this 6 is really a negative. So we can look at this now and we have a simpler problem. 9 plus negative 6, or if you prefer, 9 minus 6, which is 3. So once again, we ended up with our answer of 3. And all 3 of these methods will work on these problems every single time. There's never a time when it won't work. Now, all of these will work for a very long time, but eventually you guys are going to have to understand that these rules just have to become a part of your memory. Because when our problems get bigger, when our numbers get bigger, writing pluses and minuses for everything is going to become very tedious. If I gave you a problem of negative 68 plus 39, that's going to be a really hard problem to solve using plus signs and minus signs. Same thing on a number line. That's a huge number line. So eventually you're going to have to get to the point where you just remember the rules. But until then, this is a good visual representation of what you do. Okay? So there you go. Those are your visual representations of adding positive and negative integers. Hopefully this will help and we can get you moving forward in the future.